Okay, I want everybody to go to this page now. Some characteristics about these graphs again. Let's look at the odd degree polynomial functions. Odd degree, so is the polynomials with an exponent of 1, an exponent of 3, exponent of 5. In this course, we'll go up as high as 5. The behavior of the graph. So I'll reveal these two characteristics, and let's talk about those with respect to some graphs we've dealt with earlier. I'm going to go back to this page, the beginning of the lesson where we did the construct for understanding. So notice, this first one here is a odd degree. So let me draw an arrow here. I'm doing this from my computer at home, so that's why it's not so easy. So here's a positive lead coefficient right here. The lead coefficient is positive. It's an odd degree because it's an exponent of 3. That's an odd number. And the end behavior of the graph. Notice, as x gets infinitely small, as we go to the left for x, as it gets very, very small, the graph falls to the left. Also, as x gets infinitely big, as we look out here on the x-axis, as x gets bigger, what's happening to the graph? It rises to the right. Okay, so that's what that chart means. If we look at a power of 5 down here, we can say the same thing. I'll drag this chart down a little bit now, and we'll look at this power of 5. If we look at this one, it has a negative lead coefficient. This was the negative x to the 5. So if it's negative, as we go to negative infinity for x, the graph rises to the left. And as x gets bigger, as x becomes positive, it falls to the right. Okay, so that's how you read this odd degree polynomial behavior and coefficient chart. Let's look at the other one. Find the right page. Where are you? Here it is. I'm going to take this second chart and move it back to that same area right here. Just wait a second. We'll paste it right here. We'll get rid of that other chart. Okay, even degree polynomials. The even degree would be the power of 2 and the power of 4. Okay, let me clean up this page a bit. Let me get rid of that line. So let's look at the power of 4 over here. This was y equals 2x to the 4 down here. This was 2x to the 4. And minus 2x cubed, etc. But let's pay attention to that lead coefficient. The lead coefficient is positive. It's an even degree because it's a power of 4. As x gets bigger, the graph rises to the right. And here it says as x gets really small, it goes to negative infinity as we go out this way. Notice I'm labeling that. If we get smaller and smaller for x, what's happening to the function? It rises to the left. So that would be an example of a positive lead coefficient. Another even degree would be the other one, which would be negative x to the 4. Negative x to the 4 is this one over here. Okay, this is the negative x to the 4. And notice that the lead coefficient is negative. So as x approaches negative infinity, if we go look at small x values, what's happening to the function? It rises. Whoa, I'm looking at the wrong one. Sorry, right here. It falls to the left as x gets small, and as x gets big over here, it falls to the right. So it falls left and falls right for the negative lead coefficient.